In this lesson, we are going to calculate volume of a three-dimensional solid formed by revolving a very specific confined area around an axis of revolution. There are two formulas that you could memorize. Really, I just memorized the area of a circle formula and realize that I'm either rotating about a horizontal axis or a vertical axis. So if I want to calculate the volume of a three-dimensional solid formed by rotating an area about an axis, I realize that what's happening is I'm taking some slice right here, and I take that slice and I revolve it around, and so what I get is I get a bunch of circles. And it's called the disk method because if that circle has any thickness, it looks a lot like a disk. And so what we can do is we can calculate the area of every single circle using the formula pi r squared, and then integrate that formula over a specific domain, in the case that we're spinning around a horizontal axis, or range if we're spinning around a vertical axis. And it will give us the volume of that three-dimensional object. So volume is equal to pi r squared times the integral over the limits of integration over the space that we have our area of the radius squared with respect to x. Or if we're dealing with a horizontal slice and we're spinning around a vertical axis, we'd say pi times the integral from c to d of the radius squared dy. So we're going to try a couple of these problems, and hopefully you're able to follow along. Here we're asked to find the volume of the solid formed by revolving the region bounded by y equals x plus 4, x equals 2, and x equals 5 around the x-axis. So in order to do this, I really want to draw a reasonable looking picture. So when I draw my reasonable looking picture, I'm going to have x equals 2, that's to the right 2 units, vertical line, x equals 2, I'm going to have x equals 5, that would be to the right 5 units, x equals 5, and then I have this line, y equals x plus 4, so that means I have a y-intercept at 4 and a slope of 1, so we need a line that goes through like this. To make it so it fits in the space, maybe I'll squeeze down my scale a little bit and end up with a lot flatter line. So perhaps as a rough sketch, I could do something like that. So I have y equals x plus 4. So I'm going to be working with this section right here, which I'll highlight for you so that it sticks out a little bit. This section right here, and I'm going to rotate that about the x-axis. So whenever I do these problems, I like to draw on the slice so that I realize how that slice is oriented. In this case, I'm perpendicular to the x-axis when I spin this area around. So my formula to calculate this volume is volume equals pi times the integral from a to b of the radius squared dx. So in this case, my radius is the peak height of this very specific region. So I'm going to say pi times the integral, and we're going from low to high, so from 2 to 5, of the upper curve, so x plus 4 squared dx. So I could evaluate that, and it really wouldn't be too hard. I'd want to expand the x plus 4 squared. So I'd rewrite this as pi times the integral from 2 to 5 of x squared plus 8x plus 16 dx. So I'm going to have pi times x cubed over 3 plus 8x squared over 2, so 4x squared, plus 16x, evaluated from 2 to 5. So when I substitute in, 5 cubed is 125. We still have our pi out front. 125 over 3, plus 5 squared is 25, times 4 is 100, plus 16 times 5 is 80, minus the quantity, I have to put the 2 in still, so 2 cubed is 8, so we're going to have 8 thirds, plus 2 squared is 4, times 4 is 16, plus 32. I'm going to have pi times, I'd probably like to get a common denominator here. I'd probably go with a 3. So if I go with a 3 right here, I still have my 125. I have 180 times 3. 180 times 3 is 540. And then I have minus 8. And then I have minus this 48, and 48 times 3 is 144. So if I take 125 and subtract 144, that gives me a negative 19, and the negative 8 is a negative 27. So if I have negative 27 from 540, that should be 513 pi over 3. So that should tell me the volume of the solid formed by revolving the region around the x-axis. Let's try another. Find the volume of the solid formed by revolving the region bounded by x equals 0, y equals the square root of cosine of x, and x equals pi over 2 around the x-axis. Again, I'm going to draw a sketch. I like to see what I'm looking at. So x equals 0, that is the y-axis. X equals 0. The square root of cosine x. Well, if I was to take cosine of 0, which is 1, take the square root, I'm still at 1. If I was to take cosine of pi over 2, cosine of pi over 2 is 0, take the square root of that, I'm still at 0. So I have a feeling that I'm just going to end up with something that's still concave down, but maybe just a little bit higher than regular cosine. We're also cut off at x equals 2. So really, I'm just dealing with this region right here. This region. I could highlight it. And I'm going to take a slice that is perpendicular to the x-axis. So my volume is equal to pi times the integral from a to b of the radius squared dx. So volume is equal to pi times the integral from 0 to pi over 2 of radical cosine x squared dx. So when I square that, I still have the integral from 0 to pi of cosine x. Oh, not a pi. Yeah, there is a pi in front. What was I talking about? So when I integrate cosine, I get sine. So I'll have pi times sine of x, evaluated from pi over 2 to 0. So I'm going to have pi times the sine of pi over 2. The sine of pi over 2 is 1, minus the sine of 0 is 0, so my answer is pi. Let's try one more. Find the volume of the solid form by rotating the region bounded by x equals 0 and f of y equals y squared minus 6y plus 5 around the y-axis. So this one's different because we have a change of variables. When it comes to graphing this, I might factor that y squared minus 6y plus 5. So that'll factor into y minus 5 times of y minus 1. So I'll have y equals 5 or y equals 1. So that means that I have to hit the y-axis at 1 and 5. Since it's positive, it's going to open upwards toward the positive x values. So I could draw a curve, parabolic curve, that opens to the right and label it f of y. We also have this boundary of x equals 0. Well, x equals 0 is the y-axis. So I'm going to be finding the volume as though this region right here were rotated about the y-axis. I'm going to take that perpendicular slice in there. Drawing that perpendicular slice lets me know that, hey, I'm using the disk method to find this volume. So volume is equal to pi times the integral, in this case from c to d, because we're going with y values, of the radius with respect to y squared dy. So we're going to have pi times the integral from 1 to 5 of the radius. So for my radius right here, when I square it, it's going to turn out positive no matter what. So I'll say y squared minus 6y plus 5 quantity squared dy. So I could multiply that out, or I could just put it in my calculator. And for time's sake, let's just put it in our calculator. And I'll probably leave my answer in terms of pi because it didn't tell me to round anything. So I will type in math, and I'll go with 9. I'm going to go from 1 to 5. Again, even though it's a y up here, I type it into my calculator as an x. So I'm going to say x squared minus 6x plus 5, and I have quantity squared right here. So I'm going to need an extra parenthesis on my left as well. dx. Enter. So it looks like I have 34.13 repeating times pi. If we wanted to round to 3 decimal places, I could multiply by pi times pi and write an answer of 107.233. So I hope that gets you started on the disk method.